So going back to problem 24, we did part A. Is it in statistical control or not? And it was in a statistical control. So now we go to part B, if it's capable of meeting the design standard of 4 sigma quality, right? And for that, we're going to calculate the capability ratio and the capability index. You have the formulas and everything we need right here. So we have standard deviation, we have X double bar. What are the specification limits? So again, this is a problem that I want you guys to pause it and try to do by yourself first. And then after you do the math, come back and see how I solve it. So specification limits are here, the 12 plus or minus 0.1 ounce here. So don't mess up specification with control limits. So control limits we calculated on the previously when we worked on this problem was the that formula for the upper and lower control limits. Now we're talking about specification limits. So upper specification limit is going to be 12 plus 0.1, which is 12.1, and lower specification limit is 12 minus 0.1, which is 11.9. So these are given by the customer, okay? Different than the control limits. The control limits are the ones that we need to calculate based on the variation to see uh, if it is under control or not, if there is special cause variation occurring or not. These are specification limits. So the customer is saying, okay, from 11.9 to 12.1, I'm going to accept. So I'm going to accept this area here. Everything that's here, I'm not going to accept. I'm not going to accept. Okay, that's what we're saying. And we need to know where our distribution is. It is here, it is here, it is here, right? So these are specification limits. So let's calculate CP first. So the ratio is upper specification, so 12.1 minus lower specification, divided by 6 times our standard deviation, which is 0.05667, and that gives us 0.5882. If you guys remember from when we saw about how to interpret the results, have to be 1 to be exactly at 3 sigma level because you're dividing by 3 times 6 times the standard deviation, so 3 one side and 3 the other side. It'd have to be 1.33 to be or higher to be a 4 sigma level, right? And ours is not even 1, so it's not capable of producing a 4 sigma level. But just for fun, we're going to calculate CPK as well. So that's the minimum of the X double bar, which is the 12.0095, minus the lower specification, so 11.9, divided by 3 times. So here we're dividing, remember, 3 one side and 3 the other side, times the standard deviation. And we also have the upper minus dx double bar divided by 3 times. So like this, 0.05667, that's a 0. And we got 0.644 and 0.532. So the question is it mean center or not? So the minimum value is 0.532. That's the CPK, right? Is it mean center, yes or no? No, it is not, because those numbers are different than each other, right? So the distance between X bar and lower is higher than the distance between X bar and upper. And you can see that because to be mean center, the X double bar had to be 12. And it's not 12, it's 12.0095. So it is more towards the right, the mean, than it's supposed to be, right? That's why this distance is higher than this distance here. So it's the location is higher than it's supposed to be. Okay, and you can see by this mean. So this is the process, so not capable. And it's not mean center, and the standard deviation is too high. And that kind of concludes this problem.